Okay, so I asked you to do the first 7 questions on this sheet. Momentum and conservation of momentum questions. So number 1 is a freight train having 85 cars, and each one has a mass of 8 times 10 to the 4th kilograms. So we could find the total mass, just 85 times 8, and that will be 6.80 times 10 to the 3/6 kilograms, okay? And then it says it's moving down the track so the speed is 0.5 meters per second. So part A wants to know what is the momentum. So it's just P equals mv. So 6.8 times 10 to the 4th, times 10 to the 6th times 0.5 meters per second. And you get a momentum of 3.4 times 10 to the 6th kilogram meters per second. Okay, in whatever the direction was that the cart, so we could put here a ridge direction, meaning the original direction that the train was moving in, because the momentum and the velocity would be in the same direction. B, what impulse would you have to put on the train to stop it? Okay, if we're going to stop it, then that means its VF will be 0. And its VI was what we were given in the earlier question, 0.5 meters per second. And you're looking for impulse, J, so we know J is equal to m delta V, which is really mVF minus VI. So J is equal to 6.8 times 10 to the 6th kilograms times, and that goes to 0, so negative 0.5 meters per second. And so you get a J of negative 3.4 times 10 to the 6th kilogram meters per second. What does the negative mean? It means in the opposite direction of motion. Okay, and that is really important. So opposite direction. That's number 1. Number 2. How long? So we're looking for a delta T. How long must an unbalanced force of 500 newtons, so F is 500 newtons, act on a 15 kilogram car, so 1500 is my mass, in order to increase its speed from 5 to 15 meters per second. So VI is 5 meters per second, VF is 15 meters per second, and we're looking for delta T. So F delta T is equal to m delta V. Remember, we had F delta T equal to m delta V, delta P, and J. And we said you could pick any 2 corners. So this time the 2 corners I'm picking are the top ones because I have an F, I want a delta T, I have an M, I have a delta V. So delta T is equal to mVF minus VI over F. So M, 1500 kilograms, VF, 15 meters per second, VI, 5 meters per second, and over F, 500 newtons. 500 goes into 1500 3 times. 15 minus 5 is 10. 3 times 10 should be 30 seconds. Done. Number 3. A ball that weighs, so that's the FG, a ball that weighs 2.3 newtons. So from that we can find our mass, FG divided by G, and I'm just assuming we need to. I haven't read the rest of the question yet, and it might be a good plan to do that, but our mass here is 0.234455, let's say, kilograms. So a ball that weighs that has a velocity of 15 meters per second. So V is 15 meters per second when it is hit by a bat, causing it to move in the opposite direction. So this is VI, okay, and it would be coming towards the person. Hit by a bat, causing it to move in the opposite direction, VF, 30 meters per second, and that would be away from the batter. Okay? Find the force exerted by the bat if the blow lasts for 0.1 of a second. So delta T is and it's really 0.01. Okay, so again, you're going to do F delta T is equal to M delta V. And this time you're looking for F. So F is equal to M VF minus VI over delta T. So M is our 0.234455. And of course, we kept those numbers in the calculator, so we'll have them. Now here you need to be careful. Which one do you want to call positive? Which one do you want to call negative, towards or away? And it really doesn't matter. If we call towards positive, then away will go in as negative 30 meters per second minus positive 15 meters per second, and then divide it by our time, which is 0.01 of a second. This bracket here then becomes minus 45 meters per second. And when you do minus 45 times the mass divided by 0.01, you should get a force to be negative 1055.046 newtons. Where the negative, you have to go back, which way did we call positive? We called positive towards the batter, so the negative means away. And that makes sense. You have to put a force on the ball away from the batter if you want the ball to move away from the batter. Number 4. A car of mass 1,400 kilograms, so M is 1,400 kilograms, crashes into a solid wall and stops, so VF is going to be 0, in 0.05 of a second, delta T, 0.05 seconds. If the car was traveling 5 meters per second when it hit the wall, VI is 5 meters per second, what force did the wall exert on the car? So for part A, F delta T equals M delta V again. So F is going to equal M VF minus VI over delta T. So 1,400 kilograms. Stop, so 0 meters per second minus 5 meters per second over 0.05 of a second. And you're going to get a force that's going to be negative, what is it, 1,400? 14 times 10 to the 5? 4. I have to do it because I can't tell in my head. 0, 0 times divided by 0.05. 4 zeros. That's what I couldn't do in my head. That's where I need you to tell me. And the negative means opposite direction of motion. That's why it comes to a stop. Opposite motion. Okay? That's part A. Part B says, what is the force that the car exerts on the wall? Well, by Newton's third law, we know that if the wall puts this on the car must put an equal and opposite force back. So 1,400, I was saying 1,400. 140,000, there we go. Believe what I'm writing, not what I'm saying. 140,000 newtons, and this time it'll be in the direction of motion because it has to be equal and opposite, or original direction. Okay? Because Newton's third law says that if the wall puts a force on the car has to put an equal and opposite force back. So that's B. C, what is the impulse that the car experiences? So remember, impulse, J, is equal to, you could actually use F delta T. So J is equal to 140,000 newtons times 0.05 of a second. J is equal to, you should get 7,000 Newton seconds. And we're looking for the impulse that the car experiences. So this was the force the car experienced, so this should really be a negative, this should really be a negative, and this again will be opposite motion. Okay, because we have to use this F in there because this was the force of the car, and it was a negative. All right, number 5. says a bullet of mass .05